about a recent paper I had in HBM looking at representation of bilinguals' first and second languages and how this changes with individual differences. So, understanding a spoken language is actually a very complicated process. You have this incoming acoustic signal, and the signal is different depending on a number of factors, such as the speaker, so whether they have an accent, their gender, different features of their voice, their age, the level of noise in the environment. So these things differ between a library, for example, or a rock concert, and whether the signal has been degraded, like over the radio or the phone. So then we map that signal onto meaning. So we have stored knowledge about the world, which can map sounds that we can map those sounds of language onto. So that knowledge is also influenced by context. So what you map the word toad onto will likely differ depending on if you're walking through the woods versus whether you're looking for your parked car. So yeah, for the most part, everyone, unless they're raised in a very exceptional circumstance, can do this. So the brain seems especially tuned to acquire, produce, and process language. There's a whole network of brain regions that interact to help that happen. But things get a bit more complicated when you start considering multiple languages. So in the case of bilingualism, on top of all the complexities of processing language, we have the additional considerations like the different words for a single concept, the unique structure of each language and whether there's overlap, like in the case of plural or gender systems, and the ability to speak one language without completely mixing it up with the other. So we have these two separate languages relying on the same brain networks, yet for the most part, in at least matched bilinguals, those who are fluent in both languages, we're able to function in one language without too much intrusion from the other. So this idea of maintaining two separate representations within one system is what I'm going to be focusing on today. So there are a number of theories and models of bilingual language processing. And while they all have their own tenets, there are a few things that are mostly agreed upon. So for the most part, it's agreed that there is co-activation of a bilingual's two languages. So that is when a bilingual hears someone speaking in one language, the mental representation of the other language is also activated. So for example, when you're presented with the French word chat, bilinguals are slower to respond when also presented with the interlingual homophone than an unrelated word. So in this case, we have chat on the right here, but the English homophone chat is also presented, and a bilingual would experience interference in this case. So this competition from the unused language demonstrates that even when a bilingual is performing a task in one language, their other language is actually activated in parallel. So building on this concept of language co-activation is the idea of an integrated lexicon, or your mental dictionary. So it's generally accepted that a bilingual's semantic representations don't exist as two separate entities, but they're rather a single store of semantic information that's then accessed by both languages. So evidence for the integrated lexicon comes from behavioral, ERP, and neuroimaging studies, including the activation of the same neural regions during word processing in both languages. Also, adaptation studies have shown that when a word is primed by its translation equivalent, the level of activity in response to that word starts to decrease in areas responsible for processing semantics. So finally, theories mainly agree that both bilingual languages rely on the same network of brain regions, as I've already said. When differences do arise, they tend to be in regions related to the demands of the task, such as those involved in inhibitory control. So despite all this overlap, matched bilinguals are still able to hold a conversation in a single language. So at some level, there must be some kind of mechanism responsible for language selection, and there must be some level of separability between them in order to be selected. So a common theme in various models of bilingual language processing is that of a language node. So that's here, which is responsible for selecting the language and sending signals to regulate the other. So importantly, there hasn't been any evidence of the biological mechanism for such a node. So while inhibitory control is engaged in bilingual language processing, there still needs to be some separability between the languages in order for one to be inhibited. So evidence to date has shown that during spoken word recognition, the same language network is engaged regardless of the language being processed. So we haven't managed to find any kind of neurobiological mechanism for this kind of selectivity and inhibition. So far, I've mainly talked about matched bilinguals. So this is bilinguals who are fluent in both languages. But the bilingual experience differs vastly between individuals, and there are all sorts of circumstances that can affect language processing in the brain. For example, you can learn a language at any age. It's true that acquiring a second language is easier in childhood, but there's nothing stopping you from putting in the effort to learn one as an older adult. So this means that even in matched bilinguals, the developmental trajectory that their second language acquisition followed may be completely different. Another aspect, that's age of acquisition. Another aspect that's important is proficiency level. So this is where we stop talking about matched bilinguals and start considering all the people who are more fluent in one language than another. So it's often the case that people are more proficient in their first language, but in many cases, such as people who move to a different country as a kid, these people are more fluent in their second language. So it's been shown that proficiency level can explain activation differences throughout the language network. And there are plenty of other factors as well. So things such as the amount of time a speaker spends in each language. So they may spend more time in their second language than their first language or vice versa. Differences in language use context, such as maybe you use your first language at home, but your second language at work. And then the similarity of the two languages. So these things can all lead to observable effects on how bilingual language processing occurs. So if research shows that both languages activate the same areas, and generally differences in levels of activation are due to individual differences, why don't bilinguals constantly mix up their languages? So where's the separability happening in the brain? What's the underlying mechanism of that language node? So to get at the answer to these questions, we need to look beyond traditional univariate analyses. Contrast between languages can tell us where differences in level of activation rise. So in the case of bilingualism, contrasts have told us that the same regions are activated for the same language, for each language. So, you present one language, it activates, and you present the other language, it activates in the same area. We can establish that both languages use the same area to the same degree. But what they don't tell us is how information is actually being represented within those areas. So multivariate pattern analysis, or MVPA as I'm going to call it for the rest of the talk, is one way of getting at this concept of neural representation. It allows you to look at the pattern of activation within a region and to determine whether that pattern is the same or different between two conditions. So I'll just give an example. Say we wanted to see whether a brain area responds differently to houses and faces. So we would present our subjects with a series of houses and faces, face, house, house, face. The average amount of activity across a certain number of voxels may be the same in each condition. So houses and faces activate to the same degree within a certain ROI, region of interest. But if we look at the actual pattern of activity in that region, we see a difference. So the pattern here looks different to the pattern here. So within each participant, we look for areas that have a pattern of activity that correlates higher within a category than between. So we would look for an area where faces, the pattern of activity correlates more with other faces than with houses. And the same logic can be applied to spoken language processing. If we present participants with words in each language, we can then determine which areas activate to both, and then look at the representational patterns within those areas. So are they representing different conditions the same or differently? So using this technique, I set out to answer the following questions. First, do we maintain two separate language representations within a shared language network in the brain? And given the influence of proficiency and age of acquisition on language processing, do these factors affect language representation? That is there more or less overlap depending on how proficient you are or how early you learned your second language? So, to answer these questions, we recruited 32 adults who spoke English as a first language and who had learned Mandarin as a second language. All participants were living in Beijing at the time, which is where we did the testing. And they came from all over the world, but were, for the most part, British and US nationals. Mostly grew up in the USA and UK. Uh, Mean age of acquisition was 18, but it actually ranged from 0 to 28. So that's a pretty broad range of ages of acquisition from, early childhood all the way up to adulthood. And we tested proficiency using the test of English as a second language and Mandarin proficiency using the HSK. So these are both pen and paper tests that measure vocabulary, grammar, reading, and writing. And English proficiency ranged from 73% to 100%. So this just shows even within your first language, there's still quite a big range of proficiency levels. And Mandarin proficiency ranged from 13% to 77%. So the difference between English and Mandarin proficiency ended up being 10%, where they were quite matched in their proficiency, to 79%, where they were very, very unmatched in their proficiency levels. And in all cases, the speaker was more proficient in their first language, in English. So as you can see, we had a lot of variability in age of acquisition and proficiency in our sample. So to engage spoken word recognition, we used a picture word matching task. And we use this task because it requires the listener to access both the phonology and the semantics of the word and to evaluate whether they correspond. So participants were presented simultaneously with words and pictures. The pair either matched, such as in the case of coffee here, or did not match in the case of this table baby pairing. So our subjects performed the task in both English and Mandarin, and we had 40 matching and mismatching combinations of words and pictures. There were 8 blocks that alternated between English and Mandarin, and then we also counterbalanced which language was first. Beforehand, we matched the words within and between languages on frequency of use and the number of syllables or characters. And we also made sure that the pictures were equally familiar across languages to avoid any cultural effects, because we know some images can be culturally tied. So the first step of the fMRI analysis was to perform the conjunction map. So to see whether areas activated, to see which area is activated for both English and Mandarin. So we first pre-process the data using fMRI prep, where you just put the data in bit format and it spits out your pre-processed data. We then ran univariate contrast against baseline, and we did this separately for English and Mandarin. So we looked at English against baseline and Mandarin against baseline. And then these were fed into the conjunction analysis, where we looked for areas that significantly activated and across both languages. Then we created a mask from these results to get the co-activation mask. And then we used this mask to run our MVPA. So in MVPA, you can choose either to look at representational patterns within a single ROI. So if you say you want to look in the superior temporal gyrus, you can mask off just that area and run your MVPA within that entire ROI. The other option is to look in a larger search space, such as a whole brain area, or in our case, a larger mask. So as we used a large search space, as defined by our conjunction analysis, we needed to divide up the space into smaller pieces to look at the representational patterns surrounding each voxel in the brain. So this is called a Searchlight, where you define a sphere of a certain size and you move it around the brain, performing your MVPA at each voxel and looking at the pattern of representation surrounding that point. Okay, so once we had our search space, we performed MVPA, which in our case was a split half correlation analysis. So that's just a type of MVPA. So you remember that we had alternating runs of English and Mandarin, and our analysis involved dividing our runs into odd-numbered English runs. So that was every other English run, so 1 and 3. Even-numbered English runs, so that was 2 and 4. And then odd Mandarin runs and even Mandarin runs. And this gave us 2 halves of the trials in each language so that we could then compare each language both to itself and to the other language. So here we've got the odd Mandarin runs being compared to the even Mandarin runs, and the same for English. And then we can also compare between languages. So once we calculated the correlation coefficients for each cell, we then ran a t-test to determine whether the mean of the on-diagonal, so that's within language, so Mandarin, Mandarin, and English, English, we checked to see whether that was bigger than the off-diagonal, so between language, so English and Mandarin. Okay, so finally, to determine whether individual differences in proficiency and age of acquisition actually predict the amount of overlap between languages, we then conducted a linear regression. So each participant's Searchlight MVPA results were entered into a regression, and we ran separate regressions for proficiency, in which we used the difference between first and second languages as our measure, and for age of acquisition. Okay, so moving on to the results, starting with the conjunction analysis. So as you can see, there was a lot of overlap between languages, as we expected. We see all the typical areas of the language network, such as the inferior frontal gyrus and posterior superior temporal gyrus, as well as perceptual areas such as primary visual and primary auditory here. And then we also saw the ventral and dorsal visual streams. So that's a bit more in here. In terms of activation levels, the results of this conjunction analysis fit well with what other studies have shown, in that there's a large amount of overlap between languages. So at the univariate level, we see a lot of evidence that a bilingual's first and second language activate the same areas during lexicosemantic processing. And although it wasn't part of the main study, I also want to show you areas that differed in levels of activation between the languages. So note that a difference here doesn't actually mean that both languages didn't activate this area, it just means that one language activated it more. So areas where Mandarin activated more than English are shown in blue, and where English activated more than Mandarin are shown in orange. So Mandarin areas are clearly activating more in the superior temporal gyrus or primary auditory cortex here. I'm not going to go into too much detail here because I didn't actually dig deeper into any of these effects, but it's possible that this is driven by the low proficiency speakers. Maybe they were putting more effort into listening to the tones in Mandarin to perform a task. And then English showed more activation in small areas throughout the occipital cortex here. So as you can see from these two analyses, even with small differences in activation levels, there are still huge swaths of the brain that activated significantly to both languages. Okay, for the group level in MVPA, we actually found no areas that, again, as a group, shows significantly more similarity in the pattern of activation within language than between language. So this means that within the areas that activated for both languages, there were no differences in how each language was represented. This suggests that they are in fact integrated. So again, this fits well with theories of bilingual language processing, which for the most part propose that languages are both co-activated, share an integrated lexicon, and rely on the same areas for processing. However, our sample was extremely variable in terms of their bilingual experience. So age of Mandarin acquisition, again, ranged from 0 to 28, and the difference in proficiency levels between languages ranged from 10% to 79%. So it's not unexpected that there was no consistency within the group. So what we need to do then is look at the results of the regression analysis. Okay, So when looking at the effect of proficiency, we see several areas that show a positive relationship with proficiency. So this means that as the difference in language proficiency increases, so does the difference in how each language is represented. For example, we see this relationship in the left pars triangularis, that's up here, or Broca's area, as well as part of the left superior temporal gyrus, which is part of Wernicke's area. We also see this in the right supramarginal gyrus, which is involved in auditory motor integration during word recognition. So again, dissimilarity increases with the difference in proficiency. So with a greater difference in proficiency, the languages are more separate in these areas, in their representations. Again, this fits with current theories that suggest that in matched bilinguals, we'd likely see complete integration of their two languages within these language processing regions. Interestingly, we also saw a similar relationship within the ventral visual stream, which is an area important in object recognition. So this means that when there are bigger differences in proficiency between a first and a second language, there are bigger differences in representation in the visual object recognition pathway. So note that the same pictures were used in both English and Mandarin, and they were matched across for cultural reference, and runs were counterbalanced between the subjects. So it's unlikely to be due to familiarity with the object itself or any sort of adaptation effects. So the only manipulation here is which language the spoken word was presented in. So this suggests that there's some kind of top-down modulation of high-level visual processing influenced by the linguistic context. When looking at the effective age of acquisition, we actually see more evidence for this differentiation within the ventral visual stream. So that's over here. This is visual area V3, and that showed, again, greater separability in representation, but this time with later ages of acquisition. So the later Mandarin was learned, the more different the representations in this area. So you can see here. However, we also saw the opposite pattern in other areas. So for example, in the right insula here. So the right insula has been, again, in this area, we see bigger differences in representation at earlier ages of acquisition, so that's important to note. So while the left insula has been implicated in various aspects of language, such as articulation and speech planning, this is the right insula. And the right insula has been implicated in decision-making and inhibitory control, and we know these things are important in the current task. So the greater separability of language representation in this area may reflect differences in how inhibition of the language not in use is performed. Okay, so let's unpack this a little. So in the study, we investigated the hypothesis that bilinguals will maintain similar, overlapping lexical representations of their two languages. And what we showed is that when looking at areas that activate for both languages, there's a high degree of overlap, supporting the idea that both languages rely on the same brain regions. We also showed that there were no differences at the group level in neural representation in any of these jointly activated regions. However, we had a highly variable sample with a large range of individual differences among our bilinguals. So because of this, what we can say about these results is that there are no regions involved in bilingual word recognition in this current sample that universally represent languages differently. We also investigated the hypothesis that individual differences predict the degree of representational similarity between languages. And what we found here is that they do. So with regard to proficiency, it seems that higher proficiency leads to more integration of the two languages. And we showed this throughout the language network. With regard to age of acquisition, we mostly saw significant relationships in areas that are not primarily language processing regions. So specifically, the right insula showed more language separability at earlier ages of acquisition. And again, this actually fits well with some bilingual word recognition models, such as the BID, which is the Bilingual Interactive Activation Model Developmental, which proposes that inhibitory connections between translation equivalents develop over time. So it's possible then that the right insula plays some sort of role in this inhibition. We also found separation correlated with both age of acquisition and proficiency in the ventral visual cortex. So this finding provides support for the label feedback hypothesis, which proposes that language influences the perception of visual objects. So here we found that later ages of acquisition and lower proficiencies led to greater separation in this area, suggesting that the language in use has a greater influence on perception in unmatched bilinguals than in matched bilinguals. So there are a few limitations and some future directions that I want to discuss. So although we found representational dissimilarity throughout the brain depending on individual differences, we failed to find any reliable separation at the group level. So the main explanation for this is probably the high variability in our sample. So because these effects are probably quite subtle, we would need a sample of matched bilinguals, preferably those who learn their first and second language at the same time to similar proficiencies. Within a group like this, it's possible that we would see areas of representational dissimilarity emerge. However, this isn't really representative of what bilingualism is. So as a whole, bilinguals have a huge variety of experiences. Thus, if we want to understand how they function in each language, we have to take this into consideration. We have to consider bilinguals as a whole, including all of their variability, rather than looking at a particular subset. So that's one option, to look at matched bilinguals. A better solution, then, I think, is to use a larger sample. So given the variability in bilinguals, this is probably a more ecologically valid approach. If there are regions that are universally representing languages differently, like regardless of age of acquisition, proficiency, and all the other individual differences in bilingual experience, then a very large sample could potentially have the power to detect it. So I like this approach because being able to speak two languages without mixing them up is an essential part of being a bilingual. So ignoring circumstances like code switching, which is also a super fascinating area of research, even low proficiency bilinguals are able to speak one language or the other. So they might not know every word, and they might find themselves searching for translations or proper grammatical structures, but they don't mindlessly switch between languages. So regardless of these individual situations, there has to be some mechanism for separating the two languages. So it's possible here that here we didn't have enough power to detect that because of the variability within our sample. We also weren't able to find a definitive evidence of a language node, that is an actual neural mechanism for choosing the correct language's lexicosemantic information and then inhibiting the other. So we may have started to see evidence for this in the right insula. So earlier ages of acquisition had more separability of languages in this area. But more research is going to be needed looking into the right insula and using multivariate approaches to determine its actual role in language inhibition. Okay, so to conclude, I'll just leave you with a few take-home messages. So to sum up, we found that even with high variability within the sample, bilinguals rely on many of the same regions to process each language. We found that there is high representational similarity between languages. However, individuals do predict dissimilarity throughout the language processing network, including in areas related to object recognition and inhibitory control. Thank you.
Great, thank you so much. It's really interesting work.
Thank you.
And I think it's the MVPA seems very well suited to addressing this question.
Yeah, I
Is this
completely.
is it the first sort of investigation that's really applied this technique to look at these questions?
So other people have used, I actually, well, so I ran the study in my PhD, which was in 2016, but I only recently published it. And in between, I think 2018, people started using it to publish written word, so lexical processing. So just
Right.
the process of reading. And they've also found separability of languages throughout the reading specific areas.
Right, and that sort of, and yeah, please, if others have questions or feel free to type in the chat. I'll just sort of ask one now in the meantime, which I'm kind of curious about what you think this task is sort of indexing, whether it's sort of at the lexical level or semantic, or kind of like what is really being stressed in this task, and sort of what do you think would be different, sort of if you were to look at it, perhaps a bit of a different level of processing that, let's say, if there was more phonological competition or something like that.
Yeah, that's a great question. So I chose the lexicosemantic task because I wanted to tap into um, as much of spoken language processing as possible without getting into, sentence processing and grammar. So um, this task specifically taps into phonology, which greatly differs between Mandarin and English, which is why we chose those languages as well to create the most separation. Um, but then you also have to take that phonology and map it onto your lexical, or sorry, semantic representations. So the semantic representations, if there is a shared lexicon, should be the same between the languages. So we have different phonology coming in and referencing the same semantic representations. So I think if you used a different task, for example, a reading task, you would be tapping into a lot of the graphical aspects of the languages, which again greatly differ between English and Mandarin. So there might be a greater visual component. So here, I was actually very surprised to find differentiation to the degree that we did within the visual cortex, because we specifically chose the pictures to be the exact same to isolate the linguistic components. But instead, we actually saw differentiation within the visual cortex. So I think that if you were to do a different task, like again, a reading task, you would probably tap into a lot more within the visual cortex. But I think you would still see some phonological representations, because we know that reading still activates that articulation and phonology of the language as well.
Great. And Armin had a question about asking if you could elaborate a little bit more, like if you have an example of kind of what the task looked like that the participants were doing.
Oh, sure. Yeah. If you want, I can flip back to that slide. Actually, I can do it here. Here we go. So basically, the participant would lie in the scanner, and they would have the screen in the mirror above them, and they would see a crosshair to start, and then they would see a cup of coffee, and they would hear the word coffee. Um, and this would be on screen for 2.5 seconds. And what they would have to do is press a button if they matched or if they didn't match. So what they would have to do is determine what they're seeing, what they're hearing. Do these correspond? What's the meaning of the word that I'm hearing? What's the meaning of the picture I'm seeing? Do they match? Um, and then they would see a crosshair again, and then they would see another picture word pair, and they either matched or didn't match.
And so there's another question from Jess Turner asking if, so first saying that was very interesting. Do you have the capacity to do a longitudinal analysis as people are learning and becoming proficient in their second language, or is the real bilingualism a key point?
So we don't have, I mean, there's no reason why we couldn't run that study. Yeah, we don't have these people um, around anymore. They were mostly undergrads at Western who have since moved on. Um, but that would be a really great thing to do, to look at this task as language develops. There would be some sort of thought that would have to go into choosing the right stimuli in order to not see, familiarization with the actual concept. So I think you'd need a very broad set of stimuli to be able to do that. But it would be, yeah, it would be really great to look at how pattern separability within the language network changes within individuals as they improve. Yeah.
And just to sort of go back to the earlier point about the task, I'm curious too that like, do you think that there is any possibility here that there may have been some orthographic um, activation? You know, I know it's not a reading task, but you know, were these individuals able to read in Mandarin? And if so, I'm just curious, especially because you saw left fusiform genres, which is like right where the
Yeah.
VWFA is. Like, do you think that there could have been an effect there?
I'm sure there could have been. I mean, reading and language are so tied together, right? If you activate, especially if you're in an environment where you're learning to read Chinese, I think a lot of these students were at Beijing Normal University um, as as visiting students. You know, their first language is English. They were there to either improve their Mandarin or um, to learn it in the first place. So I think if they're immersed in a context where they're really learning to read Mandarin, they're immersed in this new city where they are experiencing these graphemes and the language in written form. I'm sure that it would also activate some orthographic patterns as well. Yeah.
And so the next question from Martin Norgard, is it a confound that Mandarin is a tonal language? Would you see the same results with two non-tonal languages? The extra activation for Mandarin and auditory cortices could be due to the tones, right?
Yeah, yeah. So we actually chose Mandarin and English because they differ so much. So that was something we intended to do, introduce as much separability between the two languages. Um, because MVPA isn't sensitive to the level of activation, only pattern of activation, you know, you Z-score out, you create Z-score of the data, so there's no difference in the level of activation doesn't actually influence the outcome. So it can't be due to differences in level of activation. I wouldn't say it's a confound that we introduced a tonal aspect to things because that was intentional. We wanted to show greater separability. Um, but you'll notice that we didn't, well, we saw a difference in levels of activation. We didn't see differences in pattern separation within primary auditory cortex. I mean, there was that posterior part of the superior temporal gyrus. I would say that's a bit later in the processing stream than primary auditory cortex. Um, so we did see differences in level of activation, but we actually didn't see them separating the languages based on that.
And so related to that too, like how much do you think language distance is playing into this? And sort of, you know, do you kind of have plans to maybe look at other languages?
Um, so I mean, that's definitely a future direction for sure to look at whether the dissimilarity of the languages can influence pattern separability. In theory, um, based on linguistic models of spoken word recognition, the similarity of the language shouldn't, if the languages are actually integrated within the language network and within the semantic representations, you know, your lexicon, your mental lexicon. Um, in theory, they shouldn't lead to, you know, more different languages shouldn't lead to more separability. And that's based on the models. Um, my feeling is that it should. You know, if the languages are more similar, you would expect there to be more overlap. You know, you're relying a bit more on the same processes, but it's an empirical question. Yeah, that's something that someone should answer.
And I suppose I'll ask another as well, which is that, you know, I'm curious, you know, I spend a lot of time thinking about child development of language, and I'm really curious what you think about, you know, looking at younger children and what this kind of would look like where all these things are developing. So rather than sort of having a fully established semantic, you know, conceptual network that sort of the L2 is mapping onto, in the case where if children are simultaneously learning two languages and sort of building those representations, how do you think this would kind of play out?
So Again, I think I would expect things to be more integrated in that case. They're sort of acquiring these things. They know the two words for a single, a cat. Um, I feel like there would be less separability. Separability, yeah. And this is actually predicted by the BAD model, where they say early on when you're learning them, you don't have these inhibitory connections between the two languages. But as you develop, these inhibitory connections develop between the translation equivalents. So in that case, you might start to see more separation. And we sort of see this reflected in the insula, right? At earlier ages of acquisition, there is more separability, meaning the people who learned it earlier have had more time to form these inhibitory connections um, than the people who have learned it more recently, who still don't have those inhibitory connections set up. So yeah, at earlier ages, I would expect more integration would be my prediction. Yeah.
And there's another question here. It's, Jester asks, were any of the differences in articulatory networks?
Yes. So if I can find that slide here. So in the left superior, or sorry, yeah, the left pars triangularis, and then we've also got some right supramarginal generates. So these are both based. These are both important in articulation. And I think that this makes sense because articulation is a really important part of language comprehension. We've got the subvocal rehearsal. We know very well that articulation is involved in language comprehension. So yeah, I'm not surprised that we actually got some separation in these two areas, and they were all based on proficiency level. So at higher proficiencies, which is down at the bottom here, because there's less of a difference between L1 and L2, we saw less dissimilarity. So the articulation all sort of became one aspect of language rather than two separate articulatory codes. So we have our articulatory code for English, we have articulatory code for Mandarin, but the more proficient you get, the more they become similar.
And I'm curious too, is there other factors that you think are relevant for, like, other than age of acquisition and proficiency, like for example, use? Like I'm just thinking of sort of the context of these individuals that are living in an immersion type of environment in this case.
Yeah.
How do you think that might also impact this?
Yeah, it's hard to say because you would need to sort of impose that context on them, right? You would need to say, okay, imagine you're at work and now we're going to show you some work related things or some home related things. And I guess you could test whether imposing some sort of context on them changes the way they process and represent the languages. I would I would guess that there shouldn't be an impact because regardless of context, the language should still, you know, be what it is in the brain. So if you have the shared lexicon, it shouldn't necessarily be impacted by context. But as we saw, we got this differentiation in the visual cortex, and that's purely from context, the language context. So yeah, it's hard to say how that would turn out. Yeah, but you could impose some sort of context on the listener and see if it changes the separability. Yeah.
And were the experimenters bilingual, or what was sort of the language of instruction for the actual task itself?
Yeah, so this was done by our colleagues at Beijing Normal. I went to go set it up and start recruitment, and then I had to go home and they finished testing. So we had the letter of information and the consent was given in English, and so they were bilingual. Yeah, they were. I mean, you personally know some of them, so you know the level of bilingualism they have. Sort of proficient enough to communicate with English
Right.
speakers. Um, and then the task was explained in Mandarin. So
Okay.
they were sort of cued to be in this Mandarin context, but then, or in this bilingual context rather. And then, yeah, before each run, they were told which language they were about to do. So a thing would flash up and say, okay, it's English now. And so they could sort of ready themselves to do an English task. And then it would say, okay, that's over. We're doing Mandarin now. So they could sort of prepare themselves to do a Mandarin task.
Right, right. Yeah, and I think sort of some of the experiments I've seen that are really concerned about language mode of testing and all of that, like, will sort of separate as much temporally as they can the two languages. And so the fact that you've seen this sort of distinction, even when they're interleaved between languages, like suggests that there is some separability there, at least to me.
Yeah, yeah. And like there has to be, right? So a bilingual speaker can function in a bilingual
Mhm.
environment. They can switch between the two languages as needed. So, we could separate them in time, but that would be sort of getting at a different situation than a bilingual might find themselves in. I mean,
Right.
there are lots of contexts where you're just fully immersed and you're speaking one of your languages all the time, but I think part of the bilingual experience is being able to manage these two languages.
Are there other questions out there? There's lots of people thanking you in the chat for
Thank you so much. I wish I could
giving
see
a
the
fascinating talk.
chat. Thank you.
Hello. Hi, this is Armin. Can I ask a question myself?
Sure, yeah.
Yeah. Hi. So I just want to make sure I understood your point. It was very interesting work. What is the take-home message? Can you elaborate what's the take-home message here?
Sure, yeah, yeah. So I would say that while we didn't find um, like a very strong separation of the two languages in the language network, um, there is some separability of languages. It's mostly based on individual differences. Um, I guess I would love to say that there are regions that separate the two languages, but it looks like that's emerging with bilingual experience rather than a universal thing. Um, I know that's not what take home message is quite working, but
No, that's exactly what I was asking for. Thank you very much. And just to make sure I understood your data set, are they all first learn one language, then the other one? Or
yes. Well, we had one who learned them simultaneously, but everyone else was English first, then Mandarin.
okay. And one more question, if you don't mind. So let's say we find some specific a specific area that differentiate. How can we say if it is because of the separation of between two language or the effect of learning one language first, then the other one?
So you would have to test people who were simultaneous bilinguals to do this, I
Okay.
think. Yeah. You would want to look at people who are matched in proficiency, same age of acquisition, 0,
Right.
learn it from birth, and then see if they also separate. Yeah.
Thank you.
Thanks.
And there's another question in the chat asking it, does anyone speak more languages than the two?
Yes, there were a few people who spoke more than two languages. Yeah. Not enough to actually look at them as a variable of interest. But yeah, there were a few. I think one person spoke Hindi, and one person spoke Dutch, and there may have been someone who spoke French as well. Yeah, but we didn't have enough data to sort of make that an interesting question in itself.
Right. Yeah, I'm not really sure of the literature on this. Is there much out there in terms of multilinguals? What sort of the predictions would even be there?
Yeah, I'm not sure in terms of managing languages. I'm sure it would be more of an inhibitory control issue, but I'm not sure in terms of separability if there's much work on that.
Right. Right, well, I realize we're approaching noon, so I think we'll wrap it up here because I know people have other things to be getting to. But I just want to thank you very much for this really interesting talk today.
Thanks so much, Jeff, for having me.
And thank you all for attending. And so this is recorded. So we're going to post that afterwards for people who may have had to leave early or weren't able to make it. But thank you again, and we will see you next month for our next talk. All right, thanks again.
Thanks so much.